Today we are going to start part two of our population growth lecture. This is going to take us till the weekend, well, the long 3-day weekend, because we have Monday off due to Labor Day. So let's go ahead and let's get done with our content for the day, so that way you guys can take your quiz before the weekend. Exponential growth is the rate of population growth stays the same and the population size increases steadily. This model displays a J-shaped curve, which indicates a steady increase of population size. Now, this might not look very steady, but it is increasing at a rate. So therefore, it is increasing by relatively the same amount each time until we end up back here, and then in which case then it starts growing very, very, very rapidly. What if population size kept growing and growing? We would reach something called a carrying capacity. This is the population size that an environment can sustain. What factors do you think contribute to an environment's carrying capacity? Well, here's a few. Overpopulation can lead to insufficient supply of water, starvation and malnutrition or poor diet, unhygienic living conditions, higher risk for infectious diseases, disturbance of ecosystems. All of these things can happen in nature. All right, so insufficient supply of water. All right, this is very common. If we have overpopulation, then that means that there's probably going to be more species at a water source. Therefore, they're probably going to use the bathroom. They're going to defecate, and therefore they're going to contaminate the water. If there's a lot of animals doing this, then all of a sudden this becomes a way bigger issue. This also happens with humans. So as we're noticing, what happens with humans and what happens in ecosystems are the same exact things. The big one that overpopulation really hurts is a higher risk for infectious diseases, and that's because people are more densely populated in one spot. Therefore, it makes it easier to pass on diseases from person to person. We have something called density-dependent factors. Resources that are limited because the rate at which they become depleted depends on the density of the population that uses them. Examples of this are food, water, shelter. These are all going to limit the population size. If we do not have enough food, enough water, or enough shelter, then our population size won't be able to increase anymore, because as soon as we get to this point, as soon as we run out of food, the population cannot increase. In fact, it can only decrease at that point. That is when a population really kind of hits its carrying capacity, is when they start running out of this. And at some point then, when they run out of all this, the population is going to decrease because these species are going to move out of this area into a new area, through immigration, basically, as we learned yesterday. Now we have something called logistic growth. Okay, this actually shows the carrying capacity. Okay, this graph right here shows a carrying capacity. This model of population growth considers the carrying capacity, which we call K, and is limited by density-dependent factors. As resources become less available, the growth of a population slows or stops. This forms an S-shaped curve. Population size capped at the carrying capacity. So as we can see, it grows like it's exponential growth, but then once it starts reaching its carrying capacity up here at the top, which K is equal to 375, so this environment for Paramecium caridium has a carrying capacity of 375 individuals. That means that as soon as we get to 375, the population cannot really go over that. It can go over it just a little bit, but then that's when we get higher risks of diseases. That's when we get all of these overpopulation vectors right here: insufficient supply of water, disturbance of ecosystems, unhygienic living conditions, etc., etc., etc. Now, limiting factors. A limiting factor is something that causes population growth to decrease. We have competition, predation, parasitism/disease, drought or extreme climate, or human disturbances. All of those are going to limit population size. Human disturbances can also limit human population. So this isn't just something that happens just in ecosystems. This also happens with humans as well in cities. All of these things, with really the exception of predation. as humans, we're kind of the top predator for most, well, we are the top predator for most things. We do cause a lot of human disturbances though. So a big one here is going to be competition actually, because competition is competition for resources. Um, Resources, mates, all of those things, animals and species will all compete for. They're going to try to have the most amount of resources. That's just nature. Parasitism and disease, like I said, if we have a really dense population, diseases and parasites are going to be able to pass a lot more readily. And then drought or extreme climate, as the climate changes, it also changes the organisms that can live there. Um, if we have a really green, lush field, and then all of a sudden, all that, all the shrubs and all the grass and all the trees and all that dies, all of a sudden, then the ecosystem that was there before can no longer exist. So it has to change, which means that those organisms that were there in that green lush field are going to migrate or they're going to immigrate to a new area. Then we have something called density independent factors. They are factors that do not depend on the size of the population, but can affect it nonetheless. Examples of this are weather and climate. They can reduce a population size, but it is completely random and does not consider how dense the population is. Then we have our R strategist. Species that grow exponentially when the environment is right. It results in temporarily large populations. When the environment conditions are no longer suitable for the species, the population size quickly decreases. R is the rate, as in high rate of population growth. This is our J-shaped curve. So when we say J-shaped curve, is if this is our graph right here, it is going to increase kind of steadily, and then there's going to be a huge boom in population. Now it's going to hit some sort of a carrying capacity, and then there will be a drop of there will be a drop in the population once that happens. Then we have K strategists. Organisms that grow slowly. The population sizes are usually small and kept near the carrying capacity of their environment. K strategists are characterized by a long lifespan, a slow maturing process, and reproduction late in life. K is for carrying capacity, which is an S-shaped curve. So K strategists will always try to stay near that S-shaped curve. Whales, most mammals really are going to follow this kind of a curve. Okay, this brings us to our weekend now. This video is a little bit shorter because I've been breaking it up into kind of 2-day lessons, I guess. Starting next week, our lessons get longer because we are starting school earlier. Your guys' grades are pretty much updated. Everything from last week has been graded. Well, most things from last week have been graded. I'm not going to say all because I still haven't graded. Make sure you're turning stuff in. Make sure that you check your grades today. Okay, there's a link on Canvas that will take you directly to IC. You guys know how to use those buttons on my Canvas page, so please press that and go look at your grade. Go check your grades, and that way then you can start off our new hybrid style of learning on the right foot. If you're still going to be an e-learner for the next quarter, next semester, or the whole entire year, class is still going to be run the same. The only difference is that you're going to be watching a lot more of the videos, and the lessons are going to be longer. Okay, we're going from 35-minute class periods to 40-some-minute class periods. So make sure that you're doing your homework. Make sure you do your warm-up. Make sure that you take your quiz. Your quiz will be your attendance for the day. That's all I got for you guys today. Have a great, safe 3-day weekend, and I will see you all on Tuesday.